recording?
Yeah.
Okay. Good morning. I'm going to talk today about voltage, current, and resistance. Who can tell me what voltage is? You guys have all been talking about in your starter projects. What's it, something? I times R, that's correct. Voltage is current times resistance. That's good. Who can describe in one sentence what voltage is? Electricity? Well, it's one aspect of electricity. That's true. Anyone? What about current or resistance?
Flow of electrons versus the resistance.
So current is flow of electrons. Spot on. The textbook definition, voltage is electrical potential, which, similar to if you have like potential energy of a thing, of this object, more potential energy when it's up here, less potential energy when it's down here, right? Same deal with voltage. More voltage means it's got higher potential to do work or to exert energy. Lower voltage means lower potential to do work or exert energy. Current is the number of electrons flowing through a wire every second, or the amount of charge flowing through every wire per second. And then resistance talks about that wire and how much resistance, basically how hard it is for electrons to go through. Now, I always like to talk about vehicles. A lot of people give like water analogies or some other analogy. I like to personify the electricity or the electrons when talking about vehicles IR. So the first thing to think of is every circuit is a loop. Right? You have positive from a battery, goes and does some work, and it comes back to the negative end of the battery. Everybody's familiar with this from every battery-operated anything. So, given that, you want to come up with a way to describe how those electrons move and why they move. Voltage is what I like to call the motivation for the electrons. Current is how many of the electrons get up and actually do the work, and resistance is how hard the task is for those electrons to do. So if you imagine yourself, each of you are electrons sitting in a battery. You've got your chair, you've got your snacks or whatever, you're sitting there, you're having a nice little life, you'd be content hanging out here for a little while, right? And then all of a sudden, I come in here and I say, I'll give you $1 if you run out that door, run around this building, or not around the building, around the floor, come back in that door and come back here. That's one lap. I'll give you $1 per lap. Who's going to get up and do that? I got one guy. Two. You guys are entitled. $1 for a lap around the building, you can make a lot of money. Anyways, I got two people going, which basically means given the amount of motivation, the amount of voltage that I supply, I got a few electrons doing laps, right? What if I said, I'll give you $1,000 to run that same loop? Who's going? For real?
Yeah.
Everybody's going at $1,000, right? Because the motivation is higher. It's the same thing with voltage. If you're a 1.5 volt AA battery, you're going to get some electrons to move because, like we saw here, some electrons want to get up and move for that little bit of motivation, and they'll do that much work for that much voltage. But if you had 100 AA batteries, you're talking about 150 volts, all the electrons are going to move. But there's another piece, so $1,000, right? You guys will do laps for $1,000, probably all day, right? How many of you would do it for $1,000 if I said, the loop is now, you walk out that door, you go downstairs, and you run to Golden and come back? Who's doing it for $1,000? I got 2, 3, right? That's a lot more work. Way fewer people are going to take that deal. It's the same thing with the electrons. If the electrons just have to go through a small resistor, like a 100 ohm resistor, or maybe a 100 ohm resistor in an LED, that's easy. A bunch more you can do that. You can do that with a AA battery. But if you're trying to get them to go through like 100,000 ohm resistor, That's way more work for them to get through that, because there's a lot more resistance. So they'll be like, no thanks, not for a volt and a half. You give me 150 volts, maybe I'll go. So that's what you want to think of when you're talking about voltage, current, and resistance. If you look at an electric fence, and it says 10,000 volts, basically that fence is saying to the electrons, you go run through that person, 10,000 volts motivation. So all of a sudden when you touch that, you get shocked. You are like 3 million ohm resistor, basically. So there's a lot of motivation to do that. In the relationship, pay attention to this. This is like half of my job as an electron. Ready? Half my job. Half my billable time is spent figuring out that equation in new applications. Now there's a bunch of different weird ways that this gets implemented, but the bottom line is voltage equals current times resistance. So if you have X voltage and you increase the resistance, what's going to happen to current? Go down. It's the same thing we saw here. If I increased our circuit from running up here on this floor to running the Golden and back, I got fewer people signing up to do that, right? Same deal, if you increase your voltage, I went from $1 to $1,000, the current went way up. So everybody's like, yeah, I'm gonna do it, for sure. So how do you apply it to circuits? Let's see, who is doing V equals IR? Nobody yet. Soon. But let's say you had a battery, and it's 1.5 volts. And you just want it to go through a resistor. Real simple. Right? And I tell you this is 100 ohms. E equals IR, what's current? What's the equation I'm about to write on the board? 100 times what? Okay, who can tell me what the answer is? Amps. This is in volts. This is in ohms. The amps. Got my job. It is really easy. It is super easy. V equals IR is no V equals IR is no big deal. Right? So when you see voltage, when you see current, and when you see resistance, the hard part isn't solving this. The hard part is envisioning in your mind what the electrons are doing and what impact your voltage and your resistance is having on your current. Or the other way around. You can relate everything to makes sense. Are there any questions about how voltage, current, and resistance works? Who feels like they have a good understanding of how, like if you had to describe to your mom what voltage was, who thinks they can do that? Okay, good. If you had to describe it to your 5-year-old brother, who thinks they can do that? It's hard, right? Okay. Okay. Any questions? Good. There's one other thing that I want to go over today. You can